Hello kids, welcome to ICSE Chemistry Hub. This is a channel which will deal with all your doubts of grade 10 ICSE Chemistry. So after looking into this channel, all your doubts about chemistry will be solved. Please do like, share, subscribe to our channel without fail, and also do give your valuable feedback to us, which will help us in improving. So today, children, we will be starting with part 2 of periodic table. In lecture 1, I had given a brief introduction about the periodic table and what is the difference between periods and group. If you have not viewed that video yet, please do go to the playlist and do have a look at that video before you continue with part 2. So children, in our previous class, we had learnt that this is what the periodic table is. What is a periodic table? It is a systematic arrangement of elements where the elements are arranged in increasing order of their atomic numbers. Yes? And then we had learnt that the periodic table is divided into horizontal lines. The horizontal lines are called as HP. What is HP, children? They are called as, the horizontal lines are called as periods. And how many periods do we have? How many horizontal lines do we have? We have 7 periods. 1, 2, 3, 4. This is the 5th period. This is the 6th period. And this is the 7th period. So how many periods or how many horizontal lines are there, children? There are 7 periods. As you can see in this diagram, this lanthanides belongs to period number 6 and actinides belongs to period number 7. Okay, so this has been placed separately outside the periodic table, because when they were placed inside the periodic table, they were distorting the shape of the periodic table. So they have been placed separately, but please do remember, lanthanides are a part of period 6 and actinides are a part of period 7. Okay, now there are also vertical lines in the periodic table. Okay, so what are these columns or these vertical lines called as? They are called as groups. And how many groups do we have in the periodic table? We have, as you can count, this is group number 1, or we call it as group 1A. This is called as group 2, or we call it as group 2A. This is group 3, 4, group 5, group 6, group 7, group 8, group 9, group 10, group 11, group 12. This is called as group 13, or we call it as 3A. This is called as 14, or it's called as group 4A. This is group 15, we also call it as 5A. Group 16, or we call it as 6A. Group 17, or we call it as 7A. And the last group is called group 18, or we call it as group A. It's also called as group 0. Am I clear? So, how many groups do we have in total, children? We have 18 groups. And as you know, the group number, okay, this we had discussed in the previous video. I'm just giving you a short summary of it. The group number will tell you the number of valence electrons. Okay, so it will tell you how many outermost electrons are there in that shell. For example, if they ask you, an element belongs to 6A, okay, or it belongs to group 60, how many outermost electrons will be there in group 6A? So the answer is very simple. It will have 6 electrons. If the element is from group 7A, how many outermost electrons will be there? There will be 7 outermost electrons. Okay, so because these are small 1-marker questions that can come for the board exam. Now this is where your grade 10 chapter starts from. Okay, this is from where most of the questions will be asked. Okay, now in the periodic table you have something called as periodicity. Okay, now you have learnt the word periodic. Okay, suppose you have learnt about periodic change. What is the meaning of the word periodic change? These are those changes, or these are those properties that repeat themselves after a particular point of time. Okay, so what is the meaning of the word periodicity, children? the properties that reappear themselves, okay, or the properties that come again and again after a regular interval of time. Can you see here? These properties are repeated at a definite interval of time. When I say they repeat themselves, they can either show an increase or they can either show an decrease. Okay, so when I say the word periodicity, I mean these are those properties, be it shape, be it size, be it the metallic character. What is the meaning of the word periodicity, children? Periodicity means they repeat themselves at regular intervals of time. They repeat themselves at a definite intervals of time. Now, when I say they repeat themselves at regular intervals, I mean that they can either show an increase or they can show a decrease. But this increase or decrease will be happening at regular intervals of time. Okay, it will be shown after a particular interval of time. Okay, so these are called as periodic property. Okay, now the question is, if they ask you in the exam why periodicity is happening or why after a definite interval of time the property is again getting repeated, just write this word: because of similar electronic configuration. Am I clear? So what is the factor that is responsible for periodicity? It is the reason, the cause of periodicity is the recurrence of similar electronic configuration. Okay, now we know it is dependent, electronic configuration depends on the arrangement of electrons. So in a same group or in the same period, there can be either an increase in the trend or there can be a decrease in the trend. Now this increase or decrease, as I told you, it is because of similar electronic configuration. So I hope these two terms are clear to you. So what is periodicity, children? As I told you, periodicity is the repeatance or the recurrence of similar properties after a regular interval of time. And if they ask you in the exam why periodic properties are shown, then you just have to write because they have got similar electronic configuration. Okay. In grade 10, the periodic properties that will be dealt in detail is, first one is atomic size. Now, what is atomic size, children? The other word that is given to you is atomic radius. This is the most important trait, and today we will be discussing this trait, that is atomic size or atomic radius, in detail. The next one is ionization potential. We also call it as ionization energy. So what is the second periodic property that we have to learn, children? It is called as IP, that is ionization potential. The other word that you can use is ionization energy. The third one is electron affinity. What is the meaning of the word affinity, children? We either call it as love or we call it as attraction. So attraction of electrons or love towards electron. What is the word called as? What is the periodic property called as? We call it as electron affinity. The next word is electron negativity. Now, who will get a more negative sign? From your grade 7, we have been learning metals are electropositive, whereas non-metals are electronegative. So, if they ask you in the exam, who has got more electronegativity? Is it metals or non-metals? Always remember, metals have a positive sign, non-metals have a negative sign. So, which one will be more electronegative, children? Of course, it will be non-metals. The next trend is metallic and non-metallic character. Clear? This also you know. As you move from left to right in the periodic table, metals are slowly converting into non-metals. Am I clear till here, children? So the 5 periodic properties that are to be discussed in grade 10 are atomic size or atomic radius. Next one is ionization potential, or we also call it as ionization energy. Third one is electron love, electron attraction. What is the technical term we use? We use the word electron affinity. Next one is electron negativity. And the last one is metallic and non-metallic character. Today, we will be discussing, as I told you before, atomic radius in detail. So, without any delay, let's start. So, what is the first periodic trend that we are going to start, children? It's called as atomic size or it's called as atomic radius. Let's first deal with the definition of atomic radius. It is the distance from the center of the nucleus to the outermost shell. Okay, and please remember it is measured in angstrom unit. Okay, that is a symbol for atomic radius. Okay, so what are the 2 points you have to remember for atomic size or atomic radius, children? Atomic size or radius is the distance from the center of the nucleus, or in other words from the nucleus to whichever is the outermost shell. So it is the distance from the center of the nucleus to the outermost shell of an atom. And the second thing that you need to remember is it is measured in angstrom unit. Okay. Now let's deal with there are 2 factors, or what are the factors that are affecting atomic size. What are the 2 things on which atomic size depends? The first factor on which atomic size depends is the number of shells. Okay, now we know what is atomic size? Atomic size is the distance from the center of the nucleus to the outermost shell. So as you can see in this diagram, as the distance increases, as the number of shells keeps on increasing, what is happening to the distance between the nucleus and the outermost shell, children? You can see here the size will be small, here it will be a little larger, and here it will be the largest. So just have a look at the sentence that is written here, children. As the number of shell keeps on increasing, as the number of shell keeps on adding, what happens to the atomic size? The atomic size keeps on increasing. Okay. The next factor, or the second factor affecting atomic size, is nuclear charge. Now, when I say nuclear charge, children, it is nothing but the amount of positive charge. Please remember this, because everywhere in the periodic table chapter, this term will be used again and again. Okay, so please learn this. Whenever I use the word nuclear charge, I am referring to the positive charge. Now we know which is the positive charge in the nucleus. Nucleus is made up of 2 things. It's made up of proton plus neutron. Okay, so which is the positive charge here in the nucleus? Neutron has no charge, whereas proton is positively charged. So when I say nuclear charge, I am dealing with a positive charge, or in other words, I am dealing with the number of protons. Okay, now who will give me the number of protons, children? It is nothing but the atomic number. Okay, so in other words, I will just once again go with it. When I use the word nuclear charge, I am dealing, or I mean to say, the positive charge present in the nucleus. Okay, now we know the nucleus is made up of 2 subatomic particles. Which are the 2 subatomic particles present in the nucleus, children? We have the proton and we have the neutron. But neutron has nothing to do with the positive charge. So who is responsible for the positive charge? It's the number of protons. Clear? And who will give me the number of protons, children? It is nothing but the atomic number. Or in other words, can I say nuclear? What's the other word for nuclear charge I can use? I can use the word atomic number. Clear? Because it is dealing with the positive charge. It is involved with the positive charge. So whenever I use the word nuclear charge, I mean the atomic number. So as the nuclear charge increases, or in other words, as the atomic number increases. For example, here, the second period has been shown to you. Okay, we have lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. Okay, so if you can see here, can you tell me what is the atomic number of lithium? Lithium, hydrogen is 1, helium is 2. What will be the atomic number of lithium? Lithium is 3. Beryllium will be having atomic number 4. Boron will be having atomic number 5. Carbon will be having atomic number 6, nitrogen will be having atomic number 7, oxygen will be having atomic number 8, fluorine will be having atomic number 9. As you can see in period number 2, what is happening to the atomic number as I'm moving from left to right or as I'm moving across a period, children? What is happening? The atomic number is increasing. When I say the atomic number is increasing, I mean the number of protons in lithium is 3, the number of protons in beryllium is 4, boron, the number of protons is 5, the number of carbon protons is 6, number of protons in nitrogen is 7, number of protons in oxygen is 8, number of protons in fluorine is 9. Clear? So as the atomic number increases, can I say the nucleus is becoming more and more powerful? Okay? As the nuclear charge increases, as the atomic number increases, more powerful will be the nucleus. More powerful the nucleus. Nucleus is having what charge? It's positively charged. It will pull the electrons towards itself. So what will happen to the atomic size? The atomic size will start decreasing because of the pull. I hope this concept is clear to you. But please do remember, what is the other word for nuclear charge? It is nothing but atomic number. So what are the two factors that are affecting atomic size, children? The first one is the number of shells and the second one is nuclear charge. Okay, so let's start with trends in atomic size across a period. What is the meaning of the word period, children? I mean, the horizontal lines are called as periods. That means from left to right, it is called as periods. Okay, we will again take the example of the second period. Which are the elements of second period, children? Lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. Now let's see what are the two factors affecting atomic size. We know the first factor affecting atomic size is number of shells. How many shells does lithium have, children? 2 shells. Beryllium, 2 shells. Boron again 2. Carbon has 2 shells. Nitrogen has 2. Same with oxygen and fluorine. Can you see in the diagram? The number of shells is 2. So the number of shells remains the same. If there is no increase or no decrease, atomic size will remain unaffected. So what is point number 1 you have to remember? As the number of shells are the same in a period, there will be no change in the atomic size. So just from number of shells, we are not able to decide what will be the atomic size because the number of shells, which is one of the factor, is remaining the same. So atomic size will remain unaffected. So we go on to the next factor. What's the next factor? Nuclear charge. What is nuclear charge, children? It is nothing but the atomic number. Clear? Who will decide the nuclear charge? The atomic number will decide. As I told you, lithium has an atomic number of 3, beryllium has 4, boron has 5, carbon has 6, nitrogen has 7, oxygen has 8, fluorine has 9. So what is happening to the nuclear charge? There are 3 protons pulling the electrons. For beryllium, there are 4 protons. Boron, there are 5 protons. So what is happening here, children? As I am moving from left to right, the nucleus is becoming more and more powerful. Okay? 7, 8, 9. It's like 3 people are trying to pull an electron. Here 4 are trying to pull. Whereas when you come to fluorine, 9 people are trying to pull the electrons. So what is happening here, children? More powerful the nucleus, more nuclear charge. As the nuclear charge increases, more will be the pull. More powerful the nucleus, more will be the pull. The moment the pull happens, what will happen to the atomic size? The atomic size will start decreasing. Have I made myself clear, children? So here it is remaining unaffected. We cannot decide. Whereas when we go across a period from left to right, as the nuclear charge is increasing, more powerful is the nucleus. More power means with more force it will try to pull the electrons. More powerful the nucleus, more will be the pull. And so what will happen to the atomic size, children? The atomic size will start decreasing. So overall, when I move from left to right, what will happen to the atomic size? The atomic size will start decreasing. Please remember this trend. Okay, please remember from left to right, the atomic size will decrease. Okay, so from left to right, the number of shells remains the same, so we cannot decide that. But as we go from left to right, the atomic size, the atomic number will increase. When I say the number of atomic number increases, the nuclear charge is increasing. More powerful is the nucleus. More powerful is the nucleus, more will be the attraction with the electrons. Okay, because we know nucleus is positive, electrons are negatively charged. So they will try to attract the electrons. Now when they attract, what starts happening to the size? More the attraction, less will be the size. So the atomic size will keep on decreasing. Now please remember here children, there is an exception with noble gases. Okay, so size of the noble gases, we know noble gases come at the end of the period, but they are much more bigger as compared to all the other elements of the periodic table. So please remember this, size of the atoms of the inert gases are bigger. Okay, you have to remember this. Actually, if the trend is actually followed, noble gases should have got the smallest size, but that does not happen here. You have to remember inert gases are comparatively bigger as compared to the halogens. Okay, that is fluorine, neon, fluorine, chlorine, bromine, iodine. Why does that happen? It is because they have already completed their octet or they have completed their duplet. So can I say the outermost shell is complete? Now, when the outermost shell is complete, instead of the attraction, what is going to happen here, children? Electron repulsion will be maximum. In all the other elements, it will be nuclear pull or it will be nucleus is going to attract the electrons. But only for noble gases, because the outermost shell is complete. Outermost shell is completed. What is going to happen? Instead of attraction, the opposite process. What is the opposite process? Electron repulsion is going to take place. So when they repel each other, they will move far apart from each other. So the size is going to increase. Okay. So this is an exception. Please do remember it, that noble gases, the size is comparatively bigger. Just say, use only 2 points here, that the octet is complete, the outermost shell is complete. And what is going to happen if the outermost shell is complete? They are going to have electronic repulsion instead of nuclear attraction. Clear, children? So in period number 2, as I had shown you in the diagram, lithium has the highest size or the biggest size, and fluorine's atomic size will be the smallest. Okay, because we know from left to right, the atomic size is going to decrease. Clear? Okay. Neon has a comparatively larger atomic size because neon is a noble gas. And because its outermost shell is complete, we know what is going to happen. Instead of nuclear attraction, the effect will be nuclear repulsion that is going to take place. Okay. So in noble gases, effect of nuclear pull or nuclear attraction will not be seen. Okay. Now let's go from top to bottom. What is this top to bottom called as, children? We call it as a group. Yes or no? When we go from top to bottom, we either use the word group or we say from top to the bottom part, or we say use the word group. What are the two factors, children, that are affecting atomic radius? The first one is the number of shells. Okay, this was the first factor. So what happens to the number of shells, children? We know lithium has an atomic number of 3, sodium has 11, potassium has 90. So how many shells will be here, children? Here it will be 2 electrons. Here it will be 1 electron. How many shells? 2. Here it will be 3 shells. For potassium it will be 4 shells. So as you are going from top to bottom, what is happening to the number of shells, children? As I am going from top to bottom, the number of shells are increasing. And we know if the number of shells are increasing, what happens to the atomic size? The atomic size also increases. Yes or no, children? So this is factor number 1. Now, what is the second factor here, children? The second factor is nuclear charge. I have told you already. When I say nuclear charge, I mean its atomic number. Okay, nuclear charge, atomic number, both are the same. We know lithium has an atomic number of 3. Sodium has an atomic number of 11. Potassium has an atomic number of 19. Rubidium and cesium we usually don't deal with. Okay, so can you see here, as I go down the group, what is happening to the nuclear charge? The nuclear charge, or in other words, the atomic number is increasing. The nucleus is becoming, nuclear charge increases. The nucleus is becoming more and more powerful. More powerful the nucleus, more will be the pull over the electron. Now, more it pulls, what is going to happen to the atomic size? The atomic size is going to decrease. Clear? So, here can you see here, children? One place the atomic size is showing an increase, but the other factor, because the nuclear charge is increasing, the nucleus is becoming more powerful. What is happening to the atomic size here? The atomic size is decreasing. So one place there's an increase, one place there's a decrease. Now the question is, which one should we follow here? Okay, so please do remember, always in periodic table, increase in the number of shell overweights the increased nuclear charge. So if you are given an option between number of shells and number of atomic number or the nuclear charge, nuclear charge is not the priority here. Okay, so whenever there arises a situation where you have to decide which one to take, will it be nuclear charge or will it be number of shells? Always remember, the other factor, that is the increase in the number of shell, will always outweigh the nuclear charge. Nuclear charge is never our priority. So which one will we always take into picture, children? Which is our priority? Which factor will overweigh this? The number of shells will overweigh the increased nuclear charge. Okay. I am once again telling this, when we go down a group. When we go down a group, what happens to the number of shells? We know the number of shells will increase. And if the number of shell increases, the atomic size will definitely increase. Okay, what's the next factor? The next factor is nuclear charge. Who gives us the nuclear charge, children? Atomic number gives us a nuclear charge. So if the atomic number is increasing, which happens, yes or no? Lithium, sodium, potassium. Lithium is 3, sodium is 11, potassium is 90. Okay, the nuclear charge is increasing, or in other words, the nucleus is becoming more and more powerful. More powerful the nucleus, more will be the pull of the electron. So as the nucleus becomes more and more powerful, what happens to the atomic size? It should actually decrease. So one place it is increasing, one place it is decreasing. So here you have to remember, nuclear charge is never our priority. Okay, so this factor we will just cancel it off. Just read the sentence here. Increase in the number of shell dominates. Okay, so this factor is a higher preference now as compared to the nuclear charge. So always remember, nuclear charge will never given a priority. It never dominates. Okay, in the whole periodic table chapter, please remember this, that nuclear charge is not our priority. So always, which will be our next factor, becomes the priority. So increase in the number of shell dominates over increase in nuclear charge. So what is the factor shown here? Atomic size down a group will always increase. Whenever you study about atomic size, what is atomic size? Atomic size is the distance from the center of the nucleus to the outermost shell. Always remember, especially this slide, when I go from left to right, my atomic size is going to decrease. And when I move from top to bottom, when I say top to bottom, I mean down a group, it is always going to increase. So if they ask you in the whole periodic table, which is the element which is smallest atomic size, it will be fluorine. Clear? These are the questions that are asked in the board exam. So which element? You have to see only this much. By the way, please remember the first 20 elements. So if they ask you which element in the periodic table has the smallest atomic size, we know from left to right the atomic size will decrease. So the smallest atomic size will be somewhere here. And we know noble gases are an exception. So which is the element which is having the smallest atomic size in the whole periodic table? It will be fluorine. Which is the element which will have the highest or the largest atomic size? It will be francium. Okay, so this has the largest atomic size. Please remember this step. Left to right, atomic size will decrease. Top to bottom, the atomic size will increase. Clear? I hope this periodic property is clear to you. Please keep learning. Please keep revising. And please do learn the first 20 elements of the periodic table. Children, please do stay tuned because our next part is going to deal with one of the most important periodic trend, and that is going to be ionization potential. Many children have a doubt with that. So I'll give you an easy method to remember it. So please stay tuned. Please do like, share and do subscribe our channel.